Right, welcome to a Maths Brownie video. It's one of the first in a series called Working on Display, where I'm hoping we can practice how to present our working to longer GCSE style maths problems. So today we're going to look at a tricky topic and a tricky type of question that's called proof of congruence. And a lot of people really struggle with these in the exams, so we're doing really well if we can get this understood. So step one of laying out a problem like this is just to check you've understood the problem. So take a moment, pause the video, write down the question, certainly copy the image, and study it. Think, is there anything important we're being told? Don't commit anything else to writing until you've formed the plan. So the first thing I notice when I read this question is the fact it talks about two squares. So I look at the image and think, can I see two squares? And I can. The ABCD square's a little bit tilted, but it's still a square. Also, prove the triangles are congruent. And I remember the conditions for congruency. Side, 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 side angle, side. This is the sort of thing we look for congruent triangles. So now we're going to plan a route through this problem. And the main reason these are tricky, in my view, is that there's lots of overlapping lines and angles everywhere. Something I find helpful is to draw the triangle separately underneath. So I'm going to draw BCE first, and I'm keeping it in the same orientation as the image and labelling it clearly. Then next to that, I'll draw BAG, and I'm deliberately not overlapping them. And there we are. They're not perfect. They will do. Now step 3. Let's actually complete the proof. It is a proof, so every step needs to be correct, and we need to make our reasons clear for each step. I use a table to collect the information and make that clear. So we collect our statement. Oh, my handwriting on this tablet's rubbish. And we collect our reason. And this is common for a lot of geometric proofs, but especially our proofs of congruent triangles. We're trying to spot why these triangles we've drawn are congruent, why they are the same shape and size. And they visually look the same shape and size, but how can we show that? Well, look at the square ABCD. Notice that BC length is part of one of our triangles. We can label that on our unlabeled triangles below. So that BC length, and that BC length is on a square with AB. So the BC length on this first triangle is equal to the AB length there. Let's write that down. That's going to be useful. CB equals AB, and then the reason is because lengths on a square are equal. So be careful to hit the keywords there, length and square and equal, but there are lots of ways you could write that have the same meaning. And now we've seen that square, we can see the other one, right? We've got this length here, BG, so the B should be there, shouldn't it? We've got this length BG. That's part of a square. And that's the same length as EB, which is on the same square. So now we'll write that, but now we've got two sides, BG equals EB, and it's this same reason. It's because lengths on a square are equal. You could write it again, but you can also do what I've just done there. So this is good, and we're seeing they're not right angle triangles, but we've got two side lengths of the triangle. So we're very near our conditions here. We've got either maybe side, 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 or side angle side. The third reason is definitely something that's harder to spot. We kind of want these lengths EC and AG to be equal, and they are, but there's no obvious reason that we know they are. You know, how do we prove that they are? Well, we're actually going to use the side angle side condition. We're going to notice that the angle in between the lengths we're given here is equal to this angle here. And if we look at the original diagram, we'll see why. If we let this angle ABE equal, let's just say x, but it doesn't matter what that equals, then that is added on to this right angle in the square, and ABG must be 90 plus x degrees. And similarly, EBC, so EBC, well, that's also a right angle. It's a different right angle, but it's still part of a square. So EBC is 90 plus x degrees because the interior angles of the square are 90, and they both share this little x part. So let's write that as our reason. We've got ABG, little hat shows the angle, is equal to EBC because they are both 90 plus x degrees. We've now got all three reasons we need. We can now once and for all state a conclusion, and we must make our conclusion clear. This is part 4, right? Check and communicate your answer. Well, our conclusion here is that the triangles BCE is congruent, and we have got this flashy little symbol for congruence, but you can just write the word. Triangle BAG, because they meet the condition side, angle, side. Right, I hope that's helped. I'm still learning this. There are some more problems. I'll save them in the description below, and hopefully you can click a link there. So if you want to practice more of this, some other teachers have created some great resources, and I'll pop a link. Thank you for watching my first video.